What was the question?
Is phi 1 acting on the intersection of U1 and U2 always disjoint from phi 2 acting on the intersection U1, U2?
Phi 1 acting on the intersection of always. So we assumed, because obviously if they are not, we cannot do this change of coordinate if they are like, they are not, if they are, let's see if I'm not sure if I quite understand what is, if phi 1 acting on, this is where the language thing comes in. If he has written it on the thing, let's see if I can decode this. If phi 1 acting on the intersection, so let me go back to slide. This will probably help. Or maybe here, this slide is best. So he's asking if phi 1 acting on the intersection of, so phi 1, here's phi 1 acting on this, on this, obviously it takes it to this. So this is phi 1 intersection of phi 2, yeah. And then what's the second part? Always disjoint from, always disjoint from problem. Can you hear me?
I hear you.
Yeah, sorry for that. I knew something would happen in these things. Yeah, so let's see. Let me check the chat. I believe I was. What was the thing I was trying to convey to Bob? And there are more things on the chat. So Barry is saying, you are saying we need chat to be able to. Yeah, so that's very interesting point that Barry made. Yes, because an abstract manifold, we don't really know how to do anything on a thing in a nutshell, but we know how to do things. We know how to do calculus. We know how to do things on Rn. So they are the ones that enables us, because the chart transition maps are maps from parts of Rn to Rn. So they really enables us to do that, regardless of how abstract your manifold is. So I hope that because remember, the thing, the regions of the manifold that you want to chart are homeomorphic to the region to some region of Rn. So from a topological point of view, there is no distinction between the two, right? So you can do the stuff. The benefit of this is that all the tools, the calculus and analysis, other tools that are already available to you in Rn becomes immediately available to you, right? Good luck trying to do calculus on an abstract manifold directly. uh, Yes, yes. So the chart transition map is a map from Rn to Rn. Yes, as you can see, maybe this thing. So this is Rn here. Obviously, this is just a graphical thing. Yeah, it's not. You cannot put a higher dimension in a piece of paper. But yeah, the chart transition maps are from Rn to Rn, as it says here. You see. So the first one is from this part of Rn, which is phi 1 intersection of with the, so the image, so phi 1, the image of phi 1 with the intersection of u1 and u2. So this is that's why I put here, right? This is contained in Rn. So the transition maps are from part of Rn to Rn, which is why they are very useful. Obviously, they need to, yeah. Okay, yeah. So, which is why they are powerful, because suddenly you have maps in Rn that you know how to do calculus on, you know how to do all sort of stuff, right? Because they are just maps from Rn to Rn. Yeah. Okay. So. Okay, so I think I already went through this, right? Yeah. And the challenge. Okay. So now we get to part B. This is really like we'll start with this is just a review. Today I generalize it, so it's from Rn to Rm. So this is just something that I mentioned also in the thing in the last session. So a map from Rn to Rm. If we have a map, we can put them in these categories. C0, C1, blah blah blah. When f is continuous, and then if you differentiate once, once the result of the differentiation is still continuous, ck for any k, for k greater than 1, for instance, the map is called ck if it's continuous, and when differentiated k times, the result is still continuous. And C infinite or smooth, if you can differentiate the map arbitrarily many times, as many times you want, the result is still continuous. So for our purposes, this is what we will be interested in these. So when I say smooth map, I mean C infinite maps. Okay, these are very important, as I already mentioned before, is that they are the ones indeed that will enable us to define the notion of smooth manifold. Indeed, it's they are at the center of that, and also they are the structure preserving maps or diffeomorphisms. Yeah, but we'll don't worry with that. In the next session, you will know what I'm saying. So here's the thing. Here's an exercise. I hope I got it I got it right. So for each of these following maps, you see, I'm not just working on abstract. I'm doing some concrete stuff. So the challenge is for you to find out whether these are some sort of whether they are CK for some K, they are CK maps or not. Yeah. You can notice here, when I was talking about component maps, for example, this map here, this you can see this is just these three, tuple together, right? So this would be an example of this map being constructed as from these three maps. This is just the thing, but we'll come to that. So the challenge is obviously you have to do the differentiation to see whether they are infinite, arbitrarily many times you can differentiate them, and the result still. So diffeomorphism part 1. I'm saying part 1 because this is we will have a more abstract definition of diffeomorphisms when we get to smooth manifolds. But for now, this is just to give you a flavor how these things work. A concrete example, let's say, So if you have two open regions, say U1, an open subset in Rn, and then you have U2, an open subset of Rm, and then you have a map from U1 to U2. This map is called diffeomorphism if it satisfies these three conditions. Maybe I could have layered these two together, but it doesn't matter. If f is smooth, by that you can arbitrarily differentiate it, as of this definition that we were just giving, and the inverse of f is also smooth. So f has, sorry, I forgot to say, f is invertible, so f has to have an invert, and the inverse is also smooth. So this is it. So this is already telling you not not all not all CK maps are invertible, right? So the question is, so we say the two, obviously, I forgot to say, by these being open subset of Rn and Rm, obviously they are manifolds, right? I would say you can say that they inherit the subspace topologies of Rn and Rm. Sorry, there's I think there is a typo here. You can see this meant to be U2 and Rm. So we say the U1 and U2 are diffeomorphic if there exists a diffeomorphism between them. Okay, I will correct this slide to correct this typo. Okay, and the set of all diffeomorphisms from U1 to U2 is denoted like this. And obviously, if they are they are equal, you are considering only one a map from U1 to U1 from one open region to itself. Then we write this C infinite U. The question is then an exercise here is if this map here is a diffeomorphism. Just a quick challenge. Sorry for the typo and the thing. So this is a concrete definition of diffeomorphism on Rn. We will have obviously the abstract definition, which will obviously, if you consider a manifold on a thing as a thing, will coincide with this. But this is all what diffeomorphism is a map that is smooth. It has an invert, and the inverse is also smooth. So this is already telling you that this is very okay. Maybe this is best to do it in the next session about the composition of diffeomorphism, and this type of stuff. Okay.
Quick question.
Yeah.
Does the set R plus include the point 0?
That's a good question. In here, I said it's a set of positive reals. So does it not make it a topology?
Yeah, I'm not sure. It makes it, if you exclude the point 0, then it's open on both ends. If you include the point 0, it's closed at that end.
What do the others they think? Okay, I will leave it the thing. I'll probably join your session to see what you think, if I made a typo here or something. Now we go to something very important. I could have, again, this definition. We have two definitions, but just to make it clear. So we say two charts like U1 and U2. So yeah, I'm now starting to not mention the phi's, as you can, as you notice. So when I say U1 and U2, assume I'm mentioning the pair. Non-disjoint. They are called CK compatible if the composition, again, you see the composition, the transition maps coming into play. If both transition maps, the transition phi 2,1 and phi 1,2 are CK. So they are both CK for some, K greater or equals to 1. Okay. So that means if one of them, there might be one that's CK, but if the other is not CK, then they are not CK compatible. Okay, so both, no ifs, no buts, both have to be CK in order for them to be CK compatible. Okay, and one thing, this you probably see this in the textbooks. We are defining this compatibility for U1 and U2 being disjoint, but in the thing, it's normally assumed when they are we are assuming when they are non-disjoint, but we normally assume when they are the intersection is empty, we always assume that the two charts are compatible. So in fact, in the textbooks, often you will see they define compatibility either when these two are empty, the intersection is empty, or if the intersection is not empty, then they have to satisfy this condition. This is the thing. But, this is very boring. We don't want this, especially when we want to do like a transitioning from one chart to the other. So what we want is this. So again, they are CK compatible if both transition maps are CK maps. Okay, if one of them is not CK, the other one is, they are not CK compatible. They have to be, the transition maps have to be both CK. Okay, now likewise, if we have again 2 charts on an n-dimensional manifold, we say they are smooth compatible or C infinite compatible if both transition maps are smooth. Okay, so this is what we are interested in these things, is transition maps that are smooth compatible, because this is what will enable us to define the notion of smooth atlas. This is what we need for smooth manifolds. Okay, so again, both transition maps need to be smooth maps. If one of them is not smooth map, then this is not smooth compatible. Okay, so both of them. Okay. Okay, so here's another challenge, a lazy challenge. The same, I just copied and paste. So the question is, again, you have these charts, whether these charts are CK compatible or even smooth compatible. Well, you have to check as maps from Rn to Rn, whether they are, CK or, smooth. So you can see there's already a lot of good deal of calculus for you to revise, to go and check the calculus book. This is why I was saying at the beginning of this crash course that it helps to have calculus, because in practice, I mean, you can work in abstract and listen, but in practice, you have to be able to remember some of the stuff that you like doing, differentiability and this type of stuff, in order to really see what's going on. Okay. It's like my slides have gone blank. Okay, so this brings me to the material study. So for the calculus, George, I forgot to include, there was one reference that George gave about calculus. I think maybe you can share again on the thing on the chat, for those of you, if you want to revise these the stuff that this differentiability stuff, Actually, you can see some nice, yeah. Have I left the audience? Another one I recommend is this book by Serge Lan. And for the manifold stuff, these 3, I mean, you have to jump from one node to the other depending on how difficult the stuff is. I assume at this point it might be very difficult, especially these 2, because of the notation and some of the concept that they will define right straight. We haven't gotten there yet, like the notion of atlas and these things. But I recommend you to focus on charts first. Practice building charts. Practice identifying whether charts are CK, whether charts are smooth, and this type of stuff. Because in practice, this is what enables you to construct the stuff. If you need any stuff, to go any concrete, you need something, you need to feel comfortable with that. This is one of the reasons that I've taken the different approach of defining the key notions separately, so that way you can go back to them and reference separately. And the notions of chart is really very, very important. And the next session, we will put things together. We'll go through the notion of atlas, in particular smooth atlas, compatibility of atlases. Just like there's compatibility of charts, there is also that notion. And then we'll finally define the notion of differentiable and smooth manifold. And at that point, next session, you most of you, if you want to stop, you can stop, because then it will go to the purpose of what we want for this course is to know. Let me go back again. To know what this is, right? The moment you know what a smooth manifold is, you can stop, because this is what we want. The moment you know this, you are in a good position to get into Lie groups. the way that the group and again, as I was saying, the way the group structure and the manifold structure coexist together, this is something we'll do later. But for the time being, the objective of this is to take you here. Obviously, I want to go through some extra stuff. I know some of you want to go through a little bit more advanced stuff like fiber bundles and these things. I'm happy to do that, but maybe we do that as an extra, like some maybe 4 sessions extra or something for for the brave. Okay. George, have I disconnected at any before?
I still hear you and see the slides, so I hope everybody else can too.
Okay. All good. Okay. So yeah, so my thing is try to practice building charts. Even not these examples that I've given. Try to build your own examples, and obviously be familiarized with these the thing, because this will play an important role. Now, I will do the poll about the next session. I think it's pretty established now that we will do like a 2 weekly thing. The question is whether you want 3 weeks. So there is a poll. It must be like below if you check. When do you want the next session? I hope I got it right. Like 2 weeks, the 29th of October or November. So 2 weeks essentially versus 3 weeks gap for you to wrap stuff, to wrap these things ahead. Those who need more time, you probably want November to revise. Those who feel comfortable at this point, please vote, because it will decide. I only see one vote. Okay, so the transition map. Okay, yeah, I think I already answered this question, right, Barry? Whether the transition map is from Rn to Rn, which is yes, it is not from the Crowdcast is a bit strange in the presentation mode. some of the messages is like I don't see it. I don't see everything. Okay, so most people have decided for except for one person. At least the ones are online now. Most people decided to the October 29th. Is that also a good date for you, George?
Yes, that works for me. And again, I will do a study session a week from now for anybody who wants to review or work on the homework challenges. That would be the 22nd.
Mm-hmm.
I strongly encourage everybody to work through at least some of the homework challenges, because this is the point where it's going to jump into being challenging, really challenging to understand if you don't have the basics that we've covered so far.
Yeah, that's right. That's right, George. I mean, the challenges are very, very simple. I won't say trivial like the thing, but it's very important that you see what's going on with especially the concrete ones.
Yes, the challenges relate what you may or should know from low-dimensional ordinary Euclidean space to the abstraction. Yeah,
that's right. So I really encourage. It's very hard to study alone these type of things and these things, And as George was suggesting, if you are in the time zone with the other people, maybe you should organize another session. Yeah. George, you are in the US time zone, so your sessions are normally what time?
They're at noon on the East Coast. I guess 9 a.m. for any Californians.
Okay. So if that works for you, I really encourage you to join. I know Amir has been joining, and Bob, and a few others I've seen, I believe. But it's very important because um, without practicing, you will not be able to see the subtleties in the thing with the abstract concept that we are trying to go through. Especially if you want to be like use these things as a working as a practitioners. So
And this is also kind of the last chance to just review elementary naive calculus 101 and elementary linear algebra, because otherwise
yeah, that's right.
Rn can be confusing.
Yes, that's right. Indeed, it's all about it's you. This is where you will not regret getting more calculus, because even though we are working in the whole thing is about outsourcing computation to Rn, because we can do that. And so you need to know, you need to make available all these tools, that you learn in calculus. They will be very handy in the thing. For the study of manifolds, because this is, if you are a physicist, you do calculation, you need numerical results, right? You can't do it in abstract. You need a real number. Something that spits out, you want to calculate geodesic, and all these other stuff you need. So it's very very useful.
And for the mathematicians, I think it's Spivak has a really nice quote. There's a reason the definitions are hard and the proof's easy.
Yeah.
So the reason that's the reason that the definition of a chart might seem confusing, but once you have it, then anything involving charts is easy. And I'm
actually to add and the thing just to motivate you. Say that for a lot of you, for some of you, you might feel sometimes you understood something. This is normal from my experience with the people trying to get in. Sometimes in these things, you might feel like you understood something, and then suddenly another layer of abstraction comes in. You get more confused. But this is normal. It's just take a step back and come back again. Look at the thing before you were you just do a reverse before you were confused. What identify which area is confusing you, and then focus on that. And another thing is sometimes you might feel the best way to get out of difficulties to cherry pick. Say not I would just pick this and the thing, but that's very hard, because very often the stuff that are you don't like is actually plays an important role in something else. Yeah, I didn't want to share this because I had more things to add. I didn't have when I was doing the slides, but at least I think the first one will definitely resonate. So the advice here on the first one, on the first point, feeling you understood something and then suddenly you get confused again, and this is normal. It goes. This means that this is why you need to keep these things in your head, like fresh, and these things. So this stuff don't get out. This is how you overcome this this challenge of yeah. Okay, so I think we are on the hour. Yeah, so sorry, George, go ahead.
I was going to add another suggestion, which is when you're thinking things through or solving problems, don't be afraid to fail. Sometimes you go wrong and you need to backtrack, but when you do that, you really learn.
Yeah. Everyone makes mistake. I probably have some stuff there that typo or something or whatever, but yeah, being afraid is not you should be like don't feel shy nor afraid of making mistakes. It's this is how you learn, because then later you realize, oh, okay, yeah, okay, okay. Yeah, I already knew. So George already identified the thing, the typo. Atlases, not atlases.
Yeah, just one S. One of those tricky
Just one
things
S.
about English. Yes.
Okay, thank you. I will. I'll make sure in my next slides. Is the thing, as you can see, these notions of these are like intuitive notions, right? You know, you have chart, you know, you have atlas, you know, you buy an atlas to travel around the world. You know, the atlases are made of charts and these things. Obviously, you know, the way these notions are formalized might seem a bit scary and these things, but that's how the nature of mathematics, you know.
And I think that's the big hint, is that you make an atlas by combining the charts.
Yeah.
But if you look at a real atlas, there'll be an overlap. So there'll be one part of the map on the far right might be the far left of the next page. And that's your transition function, that overlap.
Yeah. And you were talking about gluing. If you glue those parts that overlap, yeah.
So this is all that the flat earth believer needs to do, is to take those maps and glue them together, but that still might not convince them.
Yeah. That's why I was saying they should have consulted a topologist. Maybe the topologist will say, look, this is what you are seeing, but you glue it and these things, you know, you glue those parts, the overlapping parts, you might get another idea or get to another conclusion. Yeah. Does anyone else has any questions or any doubts on any of the things?
And the last thing I'll add, and this will be a challenge to me next week, if anybody has some lingering questions from going back to Calc 101 or naive linear algebra 101, I will attempt to help with that too.
Yeah, that would be great. Thank you, George. And so the invitation is open for everybody. It's really encourage, you know, I really encourage you to do this, to take this offer if you can, if you are on the same time zone, because, you know, practicing is the way you get these things in your head, and, you know, they become familiar, and then you can use them as a toolkit for your stuff. Okay, so is there any other stuff that you want to add? Have I missed anything? Does anyone have any questions about what next and these things? Next, we will go to atlases and these things, you know, and you will know next we'll define the notion of smooth manifold and these things. I know it's maybe I could have covered atlas today, but I thought just, you know, focusing on charts, giving you the opportunity to practice building charts and, you know, going through stuff. So it's much more better this way, small doses as opposed to everything.
I think it was very helpful to clarify that the chart transition map is from a subset of Rn to a subset of Rn.
Yeah, so that's right. Yeah, the question from I believe it was Barry. Yeah.
Yeah, that was a very good question.
Yeah, if in any doubt, I mean, it's on the thing, like on the diagram, I guess you can see. I hope I didn't make any typo, but yeah, it was a very good question, because they are very important, the chart transition maps. They are the trick of enabling us to do calculus on stuff from an abstract manifold to something that we are very familiar with. Okay. In that case, I think I don't want to take much of your time, George, and everyone else. So in that case, shall we say, you know, I see you in 2 weeks' time or something? Unless somebody has anything else to say.
Okay, bye for now.
Okay, good. Yeah. So thank you. I will stop sharing. So thank you again, George, for doing this.
You're welcome. I at least didn't do anything wrong with Crowdcast. I was afraid of that.
Yeah, I mean it's quite intuitive sometimes. It's just sometimes uh, with the networking issues, sometimes it
Yeah,
can disconnect you a little bit. If you stay off for a few seconds, it
yeah.
will just cut you off. Yeah,
It's much nicer than Zoom.
yeah. It's much more simpler, I think.
Yeah.
At least in my opinion, you can see um, how easy it was for me to invite you and then bring you on stage as a co-presenter.
Yeah, this is something where in Zoom or other systems, it's always been a problem for me. So this was really
Yeah.
a thumbs up to Crowdcast.
Okay. Good.
So
So with that,
I'll let you go because it's evening for you. And
yes, I'm
thank
going
you.
out actually for a pint with a few friends. We are going to. I think it's Friday here, so
All
normally on
right.
Fridays one goes out for for a drink. So this is the
Okay.
last
So,
activity that I'm done now until Monday. So
yeah, I
well,
still
sometimes I
have,
send emails. Yeah.
yeah, I still have 6 hours of work and study, but thank you again. I'll see you in 2 weeks, if not sooner.
Okay. Thank you,
Yeah,
George. Have a
yeah,
good good week and a good weekend.
yeah.
Thank you, everyone. I'll see you next time.